Hi, my name is Tim Patient, matrix number 147236. In this video, I'm going to explain about the theory of the experiment Hall effect. The Hall effect is the production of a voltage difference, which we call it Hall voltage across across a semiconductor transverse to a electric current in the semiconductor and to an applied magnetic field perpendicular to the current. In this diagram, the current and the magnetic field is applied on a semiconductor and it will induce a magnetic force. And it had mentioned here the semiconductor is carry a negative charge carrier. So the negative charge carrier will force to move to the left side by the magnetic force and left the positive charge at the right side. And with this opposite polarity in the semiconductor, it will induce a Hall voltage. For the semiconductor with positive charge carriers, the positive charge carrier will force to move to the left side by the magnetic force and left the negative charge at the right side here. And the opposite polarity in the semiconductor will also induce a Hall voltage. But the Hall voltage induced by the negative charge carrier is given negative sign, while the Hall voltage that induced by the positive charge carrier will give a positive sign. This is how we define the type of the semiconductor. Besides that, to calculate the carrier concentration, we assume that it is in a steady state condition, which means the magnetic force is balanced by the electric force. And we will get a formula E equals to VB, which E is the electric field, B is the magnetic field, and V is the drift velocity of the charge carrier. And the current given with a formula I equals to NEAV, and the current density is given by I divided by area, and we will get V equals to J divided by NE. The whole field which we get from above is E equals to VB, and we substitute the drift velocity into the equation, and we will get the whole field is equals to E equals to VB divided by NE. Besides that, the whole field is also given by another equation, which E equals to Hall voltage divided by dy. By comparing these two formula, we will get the final formula here, which we're going to use in this experiment, which V divided by B equals to I divided by H and E. And the VH is Hall voltage, B is the magnetic field, I is the current applied to the semiconductor sample, and H is the height of the semiconductor sample, which is given 1 mm here, and E is the charge carrier, and N is the carrier concentration, which we in this experiment we're going to find the carrier concentration. And this is all about my Viva session. Thank you.